Welcome to Mitchell Maths. In this video we're going to have a look at velocity time graphs. There's four types of questions we're going to look at. The first type is going to be how to draw a velocity time graph when given some information. The second type of question is how to calculate the distance travelled by calculating the area under the graph. And the third question we'll have a look at drawing tangents to calculate the instantaneous velocity. And the fourth type of question will be problem solving when you've got like missing values on the axes. So the first type of question, in this one we're going to draw a velocity time graph. The first sentence is a train accelerates from a station at a constant acceleration and reaches 80 miles per hour after 5 minutes. Now what it means by constant acceleration, that tells us that the graph is going to be a straight line, because in velocity time graphs a straight line represents an object that is accelerating constantly, and if it curves that means that the acceleration is changing, so it could be increasing acceleration or decreasing acceleration, but a straight line if it's constant acceleration. It tells us that the train reaches 80 miles per hour after 5 minutes. So if we go to our x-axis to 5 minutes and go up to 80, we're going to have a straight line from 0 to 80. The next part tells us the train continues at a constant velocity for 20 miles. So what we've got is we've got a distance of 20 miles. And the train is travelling at a velocity of 80. And if we think about our speed, distance, time formula, because we need to know how long it travels at 80 miles per hour for, so we can draw a straight line along our travel graph. We do the distance, which is 20, divided by the speed of velocity, which is 80, and that gives us a quarter. And because this velocity is in miles per hour, that's a quarter of an hour, which we know to be 15 minutes. So the train is at 80 miles per hour at 5 minutes and it continues 20 miles. So therefore it's going to be 5 plus 15, which takes us to 20, because it travels at this speed for 15 minutes. The train then decelerates at a constant rate for 2.5 minutes, stopping at the next station. We know it's 2.5 minutes. Therefore, if we're going from 20, it'll go to 22.5, which is halfway between 20 and 25. So it'll be in this column here. And we'll draw a straight line down for that. So if you connect those points up with a straight line, you'll get something that looks like this. So that's how to draw a travel graph for velocity time graphs. Now in this next question, we're going to look at how to interpret the data from a velocity time graph. Question part A says calculate the deceleration of the car during braking. It's deceleration because the car is starting at 20 meters per second and it's decelerating to 0. Now to calculate acceleration or deceleration, you need to be able to calculate the gradient of the line. In this case, I'm going to calculate the gradient. I'm going to select 2 points on the line. I'm going to select the top point here and the bottom point here. That'll probably be the easiest. And to calculate the gradient of the line, you need to do the change in y over the change in x. That's the change in velocity, which is 20, because it goes from 20 to 0. So the change velocity is 20 take away 0. And I also need to get the change in time. So it starts here at about 9 seconds and it finishes at 22 seconds. Therefore, I'll be doing 22 take away 9, which equals 20 over 13. And if you work that on a calculator, it will give you 1.54. And the units are meters per second squared. Velocity is meters per second, acceleration is always measured in meters per second squared because you're dividing the velocity by the time taken. That's the deceleration of the car. The next part B tells us to calculate the total distance travelled by the car. And when you're using velocity time graphs, what you can do is you can calculate the area under the graph that gets you the distance travelled. It all comes from the equation speed, distance, time. You do speed times time, you get distance. So if you're working out the area under the graph, you're doing the speed or velocity times time taken. So what I'm going to do is I'm going to split it into two areas. You could also split it into you could do the trapezium rule if you wanted to as well. I've got a rectangle here. Velocity is 20 and the time is 9. So it's 20 up, 9 across. 20 times 9 is 180. And in this here, I've got a triangle, so that's going to be a half base times height. So it's like a half times, well, the height is 20, so it's going to be like 10, and if you go across, that's going to be, well, we sort of did that in the last question, that'll be 13. So if we do a half times 13 times 20, that will get you 130. And to work out the total distance the car has travelled, we just need to add those two values together. So we'll do 180 plus 130, and that equals 210 metres. So that's the total distance travelled by the car on the graph. Now in this next question, we want to find the instantaneous acceleration of a particle at 0.6 seconds. What makes this hard is that the acceleration is changing. We can see the acceleration is actually increasing because it's curving upwards. And because the acceleration is changing, it's very hard to calculate the gradient. And in order to calculate the gradient at that specific point in time, what we can do is we can draw a tangent. And in order to draw a tangent, what you need to be able to do is you need to line your ruler up with the line at 0.6 and draw a straight line which just touches at 0.6 and is at the same gradient. So we'd look here, you'd line up your ruler and you'd draw a straight line and it would just touch the line. And once you've got your tangent drawn, you can then calculate the gradient of the tangent to find your instantaneous acceleration. Because if you remember, the gradient on a velocity time graph is equal to the acceleration. So we'll just have a look at what the tangent looks like. So I've drawn a tangent there. It's touching at 0.6 and just make sure your ruler's at the same gradient as that point. And then what I've done is I've chose 2 points on the tangent, and I've used that in order to help me calculate the gradient. So gradient is change in velocity over change in time from this graph. If I look at the graph, I've got starts at 30. If I read down here, the scale's quite easy on the velocity axis because it's just each box is equal to 1 because it's 10 boxes for 10 metres per second. Therefore, it's 30 take away 7. So my change in velocity is 30 minus 7. I also need to get my change in time. If I look across, 10 boxes is equal to 0.2 seconds, which means that each box will be 0.02 is one box. So I will have 0.82 here, and I'm going to take away the value here, which will be 0.36 because it's 2 boxes away from 0.4, so that's going to take away 0.02 twice, 0.36. And if you work that out, it's 50 metres per second squared, because as we said, the units are metres per second squared for acceleration. Now you don't have to get exactly this value. When you're drawing tangents, there's always going to be some slight sources of error, so you might get something slightly different. but you should be close to around this value. And the final question we're going to look at is where we need to calculate the unknown value of x, which is the speed it's travelling when it's at its maximum peak. What this graph does tell us, though, is it tells us the distance the cyclist has covered. And if you remember from the second question, if you want to calculate the distance someone's covered or travelled on a travel graph or an object travelled, you need to calculate the area under the graph. And I can do that using in terms of x, and that'll give me an equation because I do know the total distance that's travelled. Let's do the first one. That's going to be half base times height. Well, a base is 0 to 16, so that's a half times 16 times x. A half times 16 is 8, so it's going to be 8x. And then I'm going to calculate the area of this rectangle here, which is going to be, well, 16 to 25 is 9, so it's going to be 9 multiplied by x, which is 9x. And if I add them together, 8x plus 9x is equal to 289. And 8 plus 9 is 17x equals 289. And in order to work out my value of x, I need to divide both sides by 17, which will cancel this out. And 289 divided by 17 is actually 17. So my value for x is 17, and that's in meters per second. So that's how to work out something if you're given the value of the distance or something like that. Write out the equation and then solve it for x. Right, thank you for watching. I hope you found that helpful. If you liked the video and like to see more, please hit the subscribe button. And for practice questions, visit www.mitchellmathsandscience.com. The link is in the description.